Guys, so here it's our second partial project. I'm Enrique. I'm here with Toño Guerra as well as with Pato Chapa. So as you can see, we chose to have problem number 2, which is actually to find the correlation between the temperature and the pounds per square inch in between this graph. This is, as you can see, P, and as you can see, T. So now the equation that we're going to work with is T equals 87.97 plus 34.96 ln of P plus 7.9 square root of P. So you see, we will use a graphing utility, and we will tell you here later on. So as you can see, we will need to first find the derivative of this equation. It's from ln of P. You will find actually it's P. It's P. U prime would be 1 over P, because as you can see, P equals 1. Okay? Since you remember that P has 1 power, 1 minus 1 equals 0. Everything to the power of 0, it's going to be 1. So it's 1 over P. Okay, so next thing that we're going to do is 7.9 over P. Square root of P, sorry. So as you also know, square root of P would be to the power of 1/2. So it's 7.91, and then it will be P to the 1/2. Okay. So now you will pass this 1/2 here multiplying, which will give us 3.995 over the square root of P, because you can see it will be minus 1, which will give you negative 1/2. You'll pass it down as it will turn positive, and it will turn to a square root of P. Okay?
So now, going on with what Enrique said, we'll continue making this rate of change. Now we're gonna make this temperature into rate of change of temperature over time. And we need to make a derivative. So this will be cancelled. This, we already know that it's 1 over P. And we have to multiply it by this number. So it would be 34.9 over P. And now we need to we just have to add this one. So it will be plus 3.99 over square root of P. And that would be our rate of change formula.
This graph shows the following function of the problem mentioned before. It's 87.97 plus 34.96 ln of P plus 7.91 square root of P. This graph shows the rate of change of T with respect to a P at 10. This graph shows the rate of change of T with respect to a P when P is 70. The following graph shows the limit of T with respect to P. We can see that there is an infinite limit when talking about when the atmosphere increases, the temperature will also increase, and this rate will be infinite in its domain and its range.